Hello guys, in the previous video we managed to solve the Advent of Code 2024 day 12 part 1, and in this video let's continue the part 2. In the previous part 1 we needed to calculate the price of the fence, and we did succeed with it. So in this part 2, fortunately the elves are trying to order so much fence that they qualify for bulk discount. Under the bulk discount, instead of using the perimeter to calculate the price, you need to use number of sides each region has. Each straight section of fence counts as a side, regardless of how long it is. Okay, consider this example. Yes, the region containing type A plants has 4 sides, as does each of the regions containing plants of type B, D, and E. However, the more complex region containing the plants of type C has 8 sides. Aha, yes, because it's this kind of S shape. Using the new method calculating the region price by multiplying the region's area by its number of sides. Regions A through E have prices 16, 16, 32, 4, and 12 respectively, for the total price of 80. The second example of above full type X and O would have total price of 436, and it was this one. Okay, yes. Here is the map of includes E-shaped region full of type E plants. Okay, yes, the E-shaped region has an area of 17 and 12 sides for the price of 204, including the 2 regions full of type X plants. This map has total price of 236. This map has total price of 368. Okay. It includes 2 regions full of type B plants, each with 4 sides, and a single region full of type A plants. Be especially careful when counting the fence around regions like the one full of type A plants. In particular, each section of fence has an inside and an outside, so the fence does not connect across the middle of the region. Aha, okay, yeah. So we have kind of duplicated fence happening. Here are the, I think, same. Yes, here is the same example. So let's first run these. Then have a text. Part 2. Yes, and then let's have a code. I think we need to copy a bit. But before that, let's think about the problem. So we need to calculate how many sides we have. So now we have understanding of how many neighbors. So if we think about here, we have with this A, we have 2 other neighbors. Yeah. And this as well, or these A's both have 2 neighbors. Okay, same goes with these 2. And then this have also 2, but since the 2 are... So basically if the neighbors are not next to each other, then there is a corner. So yeah, I think we need to calculate the kind of think this not necessarily sides, but corners. How many new corners each plant introduced? Okay. Let's actually copy this so we won't break anything here. Okay, so corner count, and this can be integer. If we think about this already a bit further, I think we need to copy this. This is, I think, something that we need to modify here, and then I think we need to modify this as well. Or not necessarily modify, but at least run. And this is something that we need to modify, definitely. Okay, so we have all the pieces here. So if we think about how this is built, it's using the looping to the plants, so it's easier to add the logic to each plant. Have a function side count, let's say, or new side count, because we are kind of interested into the how many new sides they were introduced by this plant. So we already know that if self other type neighbor count is 4, this is single plant, standalone plant, so the corners or sides it has is also 4. Then if the self other type neighbor count is 3, so basically this given plant introduced 2 new sides. What I mean by that, let's have the example of this E. So example, this X here, it has 3 other neighbors, but since we are kind of, if we think about that we traveled from left to right, we already knew about this side that we were kind of traveling with. So this given plant introduced us the end side and then the next side. So kind of how many sides we encountered with the or were introduced by the plant. Then elif basically, actually this is else case, we will return the corner count. So how many corners we did have there. Because if it's plant had 2 neighbors, other type neighbors, it might have 1 corner or 0. But then in some cases, let's see actually. So if example this has 2, or this has no, yes, this given A has no neighbors, like other type neighbors, but it has still the corner, so we need to actually calculate, catch the outside corner. And then we have this B side inner corner as well that we need to catch. Actually, how we can catch that one? So this A knows that it has a neighbor, this A as well, but this A does not, or these A's both know each other. So actually we need to check it by this A. So if it has A here, we need to also check the kind of middle, that is there this diagonal a plant, that what type is it? Okay, yes. And so let's run this. Actually we need to run that. And then we can run this. Yes, it's the default value. So here, I think this should still work. 1930. Yes, 1930 still works. Okay, good. So here we are looping and initiating the plants. So I was thinking that if we here would, so as we already know, or here go through the neighbors, if we're gonna collect the neighbors, and then in the end we just check the corners. Would that work? Maybe. We can try. So let's have a local variable of neighbors. And this could be, I guess, dictionary. So what neighbors we have actually? So we have neighbors that are our own, so same type. Then we have the neighbors of none, which is the kind of this case. So basically this outside. And then we have a neighbors of the actual type. Yes. So we have kind of 3. So should we actually go with default dict? And I think we need to from collections, I think default dict, yes. And in this case we maybe, if we use NA not applicable as a case where the neighbor is kind of friendly one, and then we can use the same. So if default dict, so I was thinking that if we have a dictionary of, so that we have like 1 is up, 2 is right, 3 is down, and 4 is left. And then if we have a default value of not applicable, that could be for the kind of friendly type of plants. And then here we would just add the rest. So in this case, we are checking the above row with same column. So this would be neighbors, neighbors 1. And this would be this. Then we would have neighbors 1. For this we can actually just use none. Then we have this case, neighbors, it's the same column below, so it's the down. So we can just use this like that. And then we can go to the next one. So this is neighbors, same row, column -1, so it's left. And left was 4. And we can just use this one here. And then we can have the default case here. Yes. And then neighbors. So this is the same row +1, so right 2. Yeah. It is this one. And then same for here. Yes. And now we have the data. We can actually check what the neighbors are. Neighbors. Oh, first argument must be callable. Okay. I think we can just do it like this. Can we see NA somewhere here? none. Yes, good. So NAs shouldn't be showing because it's the default value. So I think this looks actually quite good. Then, so we have the neighbors. So now we need to calculate the corners. So basically, if neighbors up is not NA, and then we can check the right one. Yes. And neighbors 2 is not NA. Then we can check the diagonal one. So in this case, actually, we don't yet know. So we just know that the above one was not NA, so it was not friendly. Right one was not friendly. Actually, can we check? So actually, so if this is none and this is none, let's go with this. So if both them are nones, we can just say plant dot corner count plus equals 1. Yes, let's split this up. So let's first get the outer corners. So we can then just have a elif that checks the 2 and then 3. And then increase the corner count. Yes. Um, 3 and 4. And then 1, 4 and 1. So we're gonna go through clockwise that if each of these are none, then we add the corner count to 1. Okay, then, or actually, yes. We can actually improve this because now it checks just the outer corners, but it doesn't really differ much from checking is it the outer corner, like actual where there is no neighbor plants, or if the plant is just different. So actually we could, so if we actually check that it's not NA, same for here, then I think we are able to handle the both cases of, yeah, so it's actually outer corner, like from the area point of view. Yeah, and then for inner corners, we need to kind of do this, but inner corner, so we need to check that it actually is NA. So it needs to be NA, so friendly. And then we need to check additionally that if this, so example here, we have up and right, so we need to check row minus 1, column plus 1. Is not same as plant dot type, I think. And then we can increase the corner count again. Yes. Let's make this here priority case. And here we have right and down. So right and down. So we need to get the row +1 and column +1. Yes. Then down and left. So row +1 and column -1. And then both are actually -1 for the last case. So it's the top left. And then let's run this. Let's see what kind of plants we got. Or not plants, but sides. Side. And then I think we can just copy this one. And then add comma here. Then new side count. Yes, and then let's run it. Let's also add one delimiter row there, so we can see where we are. And so we have for the R we have 4 sides, or sorry, 8 sides. Okay, that's wrong. Then for I we have 4, then another I we have 14. We should have 16. Okay, so we have something wrong. Interesting. Let's check. Where was the R? So it is this one. Do I have some issue here? Let's actually print here the plant. Print plant and then plant dot location and plant dot corner count. I'm wondering that do I have some error here? Let's see. So R. Okay, first R has 1 corner. That's good. Then we have here 1 corner. Correct. Then let's actually print the type as well. Plant type. So we can get a bit easier. So all the errors are here. Yes, then we have 4 more. And that's correct. And there is only 1 corner. Yes, correct. Then we should have 3 more R's here. Or actually there is 1 corner here. So I'm like wondering that am I now missing something? It feels that it didn't actually catch this corner. Yes, it didn't. This should have 1. Okay. So it should have down and left. Down and left. Down and left. So 3 and 4. It's map. Row +1. Do I set them here correctly? Yes, down. Okay, yeah, that's looking good. Then here we have the same row left, row column left, yeah. It looks good. Okay, let's see if we can print here the... Is this then accessing the... It should access it correctly. Okay, let's see. So if we only print the type R, so if we just get the print or if plan type R, print plan dot corner count. So let's just check that we can have the more cleaner. Yes. Actually we can, why not print all, everything we have. So 1 and 2, let's actually, just to make sure that this is not data issue, rerun the data set. This one as well, and this. Yes, it's not. Cool or good. Then let's print the neighbors. It is for this. We have, actually we have now some, okay. I wonder why, but I guess it's, so based on this it says that it's all NA. Actually, I now realize that this can't be Elif because these are not exclusive, so, or mutually exclusive, so we need to check in any case or in any case we need to check all the steps. Yes, because if the first corner matches, then we need to check the rest as well. Okay, yeah. Does it change anything? No, not really. Okay, now it did. Okay. So it actually did change. Yeah, but the print was too early. Yeah, true. Okay. So that was the problem. So we didn't check all the possible corners. Okay. Now we can drop this print off, I think, and then just run this. And then we can, I think, run this. Let's run this. Okay. So now we have the R with array 12 sides 10. Yes. I4 times 4, then another I, 14, 16, yes. C, 14, 24, 22, sorry. Correct. Another C, 1 and 4, correct. F, 10 and 12, correct. V, 13 and 10, correct. plan J 11, 12. Yes, correct. And then we can update the price count, which is the new side count. 1206. Okay, good. So that is looking good. So now we just need to comment that out, run the map again, so we can override the variable. The wrong section. Let's rerun all of these. Oh yeah, this was I think the long step that took long. So you could actually here add the print to follow up the progress. Plants left, length of current not added. Yep. Yes. I think this will run for a while, so I think I'll speed it up, so you don't need to wait for this to finish. So I'll get back when this is done. Yes, I think it's ready now. So all the plants have been processed, and then we can run this last function. Looks, I think, good. Now let's try, is our answer correct? Yes. Yes, it is. Okay, I think that's all for this video. So we managed to solve the day 12 successfully. This second part was quite intense and simple, but again this run took quite long, so that could have been optimized, but at least we managed to get the day solved. But yeah, I think that's all for this video. If you liked the video, drop a like and subscribe to the channel, and see you guys in the next one. See ya!